Hello and welcome to Cometwatch for August 2019. I had to think about the year just then. It's very hot here in upstate New York. I've got 92 degrees outside, which is the equivalent in the UK, 33.1. And this is actually going to be the last show that's going to be recorded abroad. As of next month, I am back in the UK, and let the merriment and mayhem commence, as they say, including we should now have a chance to sit down properly and plan Cometwatch in the pub, at the pub.
Yay, looking forward to that.
Yes, lots of good fun there, clinking of glasses, and maybe having to pat someone on the back when they swallow their lager or beer too quickly. But anyway, moving on. Okay. Yeah, it's gonna be a fun show. Okay, so as always, we will start with the shipping forecast, and so latest discoveries from the British Astronomical Association Comet Section Visual Observations page, courtesy of Nick James and Jonathan Shanklin. Thank you guys, we always appreciate this. So I'm going to start off with July the 17th, discovery of 2019 M2 P/Atlas reported.
Then July the 18th, discovery of 2019 M3 Atlas reported.
July the 18th again, Moorshot Bloomplod reports a Kreutz Group comet in real-time C3 images.
July the 20th, Warchop Bloomplod reports a non-group comet in real-time C2 images.
And July the 22nd, Warshot Bloomplod reports a Kreutz Group comet in real-time C3 images.
July the 27th, and Zhejiang Zoo reports a Kreutz Group comet in real-time C3 images.
July the 28th, recovery of 2014 U2 periodic Kowalski as 2019-01 reported.
And then July the 29th, Zhejiang Zoo reports a Kreutz Group comet in real-time C3 images.
Also on the 29th, our old friend Treve Prescott reports a Kreutz Group comet in real-time C3 images.
July the 31st, Warchop Bloomplod reports a Maya Group comet in real-time C2 images.
And July the 31st again, Praful Sharma reports a Kreutz Group comet in real-time C3 images.
August the 8th was the discovery of 2019 O2 A/Pan-STARRS reported.
August the 10th, Seismon Li Wu reports a Kreutz Group comet in real-time C2 images.
And August the 11th, Warshot Bloomplod reports a Kreutz Group comet in real-time C3 images.
August the 13th, and Warshot Bloomplod reports a Kreutz Group comet in real-time C3 images.
August the 14th, Warshot Bloomplod reports two Kreutz Group comets in real-time C3 images.
And August the 16th, the site was updated.
Now, as always, if there's no recent updates here, try the German Comet Group or Seiichi Yoshida's page for information, or the Liga Iberoamericana de Astronomica for observations.
Great pronunciation.
Thank you. I've been practicing that one. It's almost as fun as doing our old friend 29P. We'll get to that in a minute. So, comet magnitudes on observable region on July 31st. Pan-STARRS 27T2 is reported as a magnitude 9. It's bright, 55 degrees north to 55 degrees south, early morning, last visually observed 2019 of August.
Then we have Africano 2018 W2, magnitude 10.5 and brightening, observable 55 north to 20 north. That's an all-night object, last visual observation in August 2019.
And next is Lemon 2018 R3, magnitude 11, currently fading, and also now in conjunction, last reported in July 2019.
28P, Clamola, 11.5, bright, 45 degrees north to 60 degrees south, best in the evening, last visually observed 2019 August.
Then we have 260P McNaught, that is magnitude 12 and brightening, observable 55 north to 60 south. That's a morning object, and last visual observation August 2019.
And next is Saturn 2018 N2, magnitude 12 and brightening, 55 degrees north to 50 degrees south, the morning object, and last reported in August.
And of course, guess which one I've got? 29P SW1, or better known as Schwachmann Wachmann, 13th magnitude question mark. It varies. It has recently been an outburst, and it's 55 degrees north to 50 degrees south. Best in the morning, last observed 2019 August.
We have Catalina 2018 W1, magnitude 13. That is fading. Observable 25 south to 90 south. That is an evening object. No visual observations reported as yet.
And lastly is Pan-STARRS 2016 R2, magnitude 14 question mark and fading, 55 degrees north to 20 degrees south. It's an evening object and was last visually seen in 2019 January.
Now, the observational region, is an approximate indication of the latitude in which the comet may be seen. Obviously, under good conditions, comets may be visible outside this range. The period when visible is for the UK, but if the UK is visible for us, otherwise for 40 degrees south or the equator as appropriate. Now, the last visual observation obviously is as received by the Comet Section. Details are updated on the basis of observations published elsewhere. I will say this, beginners will often find comets fainter than about 7th magnitude difficult to locate. Always use the ESA Comet Section page for further information on positions and finder charts. Now, let's go back a little bit to good old Pan-STARRS 2017 T2, because I know you've got a beef with this, Norman.
Yes, I have. Oh, excuse me. Yes, there's been lots of observations of it recently, and although we quoted 9th magnitude, most observers, in fact nearly all of them, apart from one certain person, are saying it's 13.5 magnitude or 14, which would put it on track at the moment to be bright next year. Around about, I think it's about June next year, it should get up to about 6th magnitude. Now, one certain person has quoted it at 8.5 magnitude at the moment, when far more experienced observers, Alan Hale included, is one of those, have said it's about 14.5. So we do not know what's going on. We've had lots of more observations since this person said it was 8.5, and they are still saying it's 13.5. So it's best to ignore that for the moment. And although Seiichi Yoshida has updated his light curve, I did email him, and he said that he had to put it on there because it's been reported, but he is not altering his light curve because of it, and he still expects the comet to get up to around about magnitude 7 around about June next year.
And of course, the nice thing is this: if it is on track, it should become visible in binoculars.
Yes.
So, fingers crossed. Comets are like cats; they have tails, and they do with them as they wish. Now, back to the matters in hand. We have a guest this month, and he's an old friend of the show. And our dear old friend, would you like to introduce yourself again?
Hi, this is Jim Scottie from the University of Arizona. I like comets too.
Now, interestingly, an old comet has actually come back into the news. I know that we've been discussing it in the Cometwatch group, and that is Lexell's comet. What is going on with it? Because it was supposed to have been recovered back recently, but no one's seen it.
Yeah, I would have guessed that it was long gone, and since nobody's ever seen anything that really matched, although there is some claims now that we might have recovered it. Well, it's an interesting object, made a really close approach to the Earth in 1770, so it would have been a cool object to see, yeah. Well,
it actually helped. Go on, Neil.
Oh yeah, I was going to say, I've seen several reports. Some people say it was it interacted with Jupiter in 1779 and got kicked out, and Nakano from Japan, who's a comet orbit specialist, basically claimed that the comet was put into a different orbit but came to perihelion back in 1984. But this time, instead of having a close approach to Earth, Sun, it now only comes to just on the orbit of Jupiter. But now, of course, this 2010 JL33 asteroid has been associated because it has a strong orbital link with it, but unproven.
Right.
So, a few facts about the comet. Really, it was popularly known as Lexell's comet after its orbit was computed by Anders Johann Lexell. It was discovered by Charles Messier in 1770. It held for a while the closest approach of an object, which is at 0.015 astronomical units to the Earth. So for a long time, this was the object that we know has come the closest. I believe a near-Earth object has recently improved on that, coming in at 0.12, but it was supposed to have had a period of about 2,045 days, dimensions about 4 to 30 kilometers, and as I say, it's really vanished. It's kind of joined that little group of comets that have become infamous for being not recovered when they're supposed to have been able to. I think I may be wrong, but was it West or Kohoutek's comet that was one of those?
I don't remember myself on that one.
Well, what do you think, Jim? As Nick said, the diameter of the nucleus was about 30 or 50 kilometers? I can't remember what he said. But if it came that close and had been on the larger side of that estimate, surely it would have been a much. I mean, we're talking sort of like Hale-Bopp size or Comet Swift-Tuttle size. It would have been a lot brighter. Or do you think it was already into the stage of basically just dying already? There's no tail associated with the comet, even though it was that close.
Yeah, an object that big would definitely be an impressive object. Today, we would have probably discovered it, a long time before its close approach, especially if it had been on its original orbit for any length of time. We would have already discovered it if it, came in today, for example. But I think we found essentially all of the 4 kilometer size near the asteroids, for example, by now. There might be one lingering out there that we haven't found, but we're worried more about the kilometer and slightly smaller objects these days. But an object like this would have been, it would have put on a really nice show, comparable to Hale-Bopp, potentially years before its close approach. So it's a little surprising that it wasn't found many years before that, or wasn't linked to something that had been found years before that. Did it just come in around that time because of a close approach with Jupiter, for example? Or was it maybe a much more fragile object that looked a lot bigger than it really was, and essentially evaporated during a close approach to the sun? So I'd love to go back and observe it with modern telescopes and see what really went on.
Yeah, because the coma is described as being like over 2 degrees of sky. It was really big, and it covered 42 degrees in 24 hours in terms of movement. That must have been quite something to see.
Reminds me of IRAS Araki Alcock.
Just thinking of that one, yeah.
That object went from one side of the sky to the other side of the sky in one day. I remember observing it up near Ursa Major on one night, and I went back out the next night just to see where it was, and I started looking over toward Ursa Major, and then I look at the ephemeris, and I have to do a 180-degree turn. It's on the other side of the sky.
Crazy.
And I know that caught Sir Patrick Moore out, because I was watching a YouTube catching up on the old Sky at Nights, and Patrick Moore apologised, saying that this comet came in and it was so quick, and he'd pre-recorded a show the month before and totally missed one of the best comets in a long time, in over 10 years at that time, I think it was.
Yeah.
So completely missed it. But that wasn't a Jupiter family one, was it? That was a long period one, wasn't it?
Right, I believe so.
Yeah.
In fact, as I remember, IRAS Araki Alcock was discovered by an infrared satellite, as well as
IRAS.
IRAS, which was really, in some respects, it really did take the whole game up a whole new step, because now we had an instrument looking in the infrared, and it not only did it help discover the comet, it also happened literally simultaneously with the visual discoveries, and I think that was probably the very first time we had such a fast confirmation ever. So just for the facts, it's a long period comet. It made its closest approach to the Earth at a point 0312 AUs, 4,600 odd million kilometers. It's an orbital period of a stunning 970 years and 40.49 years. So we're not going to see that one for a very long time. Probably my great grandchildren might, if they're so inclined to, but again, even then it depends on a whole lot of things. Yeah, where it is, and just does it switch on just right and give us a good show. It did give us a very good show, though. That was the interesting thing.
Yeah.
I don't know what the absolute magnitude was, though, Nick. Have you got any information on the absolute?
12.599 for IRAS, Araki, Alcock.
Which means it's quite a dim object if it doesn't come close to Earth then. So,
yeah.
I mean, that's worse than Hyakutake, which is about 8 point something.
But
it has to be close to be good.
It has to be close to be good. It has to be just in the right part of the sky for visual and for imaging. And I tend to think if we can ever get the James Webb Telescope up into, it would be great to be starting to look at some of these comets in the near infrared. I know that really the whole point of the James Webb is to look back into Planck time and the beginning of the universe. But wouldn't it be fantastic to do what IRAS did and image and take data on a fairly decent bright comet as it comes into the solar system, into the inner solar system?
Yeah, hopefully it'll be able to interrupt its schedule and go after some new discovery early on like that. So I'm sure there's director's time.
Oh yeah,
available for that kind of thing.
Well, they did that on. I'm trying to remember. There was one of the impacts. The Shoemaker Levy 9. They interrupted all the observatories.
Yeah,
and I believe on Chris Weasley's Jupiter impactor, which we still don't quite know what it is, whether it was a comet nucleus or was it a big chunk of rock or something. But the Hubble was still in workup after its last repair mission, and everything was thrown out the window because it was just needed. It was just the right moment. Nobody thought it was going to happen. It was historic. And having those instruments, even if they weren't technically calibrated, which the Hubble wasn't at that point, allowed us to really observe and perhaps record what happens when a big chunk of rock hits the atmosphere. Thankfully, it was Jupiter doing its job of being a hoover, but sometimes Jupiter doesn't.
Well, in the case of Shoemaker Levy 9, we had almost a year to plan our impact time discovery or observations. Not quite a year, but we did have enough lead time to really make a lot of plans like that. Something that comes in really suddenly, you'd have to be a little more on your toes with.
Yeah, and maybe...
What was the... Sorry.
Go on, Neil.
Oh, I was going to say, what was the total size of Shoemaker Levy 9? I mean, diameter-wise, because I know it fragmented into dozens of bits, but what was the actual total mass?
We don't have we have an idea, but there's two different lines of investigation. One is work I did where we integrated the orbits of all the pieces back to Perigove from around the time of discovery to figure out how close together all the little pieces would be. And if you do that and you take it right straight back to the Perigove that we knew at the time, about 2 kilometers diameter for the whole thing before it broke up, is what you get. Some of my colleagues did a similar calculation, but they determined that it broke up after Perigove and was probably more like 6 kilometers in diameter. So you have bigger pieces, but that's still pretty small stuff hitting Jupiter and making a really big impact, so to speak, on us.
Do we know roughly...
sorry, go on, Neil.
I was going to say, do we know roughly when Jupiter captured it into its original orbit and then sort of dragged it in slowly?
We do have some ideas. If you integrate the orbits back in time, I think the best estimate was that it may have been captured into orbit around Jupiter sometime around the 1930s. So it had been there for 50, 60 years potentially in orbits. The orbit would actually change its shape because of external perturbations. And it would go through a series where it's a more circular orbit, not really circular, but a lot less eccentric. And then you basically get an inclination eccentricity interchange where the perigeo drops way down and and it becomes a very elongated orbit. So it can go through a couple of those cycles before it gets perturbed into a Jupiter impacting orbit. So yeah, that was an interesting thing to learn about. How long had it been there that we might have been able to discover it potentially long before the impacts. Be interesting to see that kind of thing happen again.
Definitely.
I think
on the subject of impactors, there was obviously 10 days ago there was that impact on Jupiter again. I was just wondering, do we know any more about that object at the moment? Because that wasn't predicted, was it? It was
no. Yeah, I saw the picture, but I haven't seen anything really more on that.
No, I didn't know if it had left scars like Shoemaker Levy did. It was quite a bright flash. It's impressive to see.
One question I would have. Yeah, one question I would have, did he get more than one image of it? Because if it's a single image, I'd be concerned that it might have been something like a satellite glint or something more local to the observer. So hopefully he got more than one image of it.
I mean, there is a video of it, I think.
Okay, in that case, it's probably real. So as an observer, I have to be a little more careful about that kind of thing just to make sure. I had to ask the question even. I'm glad you have an answer.
I've seen the video. I'm sure it's a video. He's done an animation of it with several frames.
Okay.
Yeah, I've seen that as well, because it was like, yes, great. I think the thing is, go on, Neil.
I was going to say, Daniel Bamberger estimated it to be around about 10 to 20 meters in diameter.
Is that all?
Yeah, that's what he thought, yeah. And he's quite good at that sort of stuff, so, I haven't seen anything else from anyone else, so that's all I've got.
Yeah. Well, even if you have an object in orbit around Jupiter, the impact speed's going to be on the order of 60 kilometers a second.
Yeah.
So if you have something coming in from outside of Jupiter, it'll be a little bit faster than that even, potentially.
Yeah.
So it doesn't take a very big object to make a really big impact, so to speak.
I think that's one of the lessons we did learn from Shoemaker Levy 9, when we actually did figure out what the size of the actual fragments were, compared, and I think the shock images were seeing just how much damage it did to the atmosphere. Because at first we saw we saw the initial impact. And then when Jupiter rotated around again, we got to see how it expanded, and it was I suppose in a lot of places, we know that certain bunches of people were poo-pooing the idea already that it's going to happen. Shoemaker Levy 9 happens and everybody goes, "We told you so."
Yeah, it was interesting going into Shoemaker Levy 9. We really had no idea what was going on. One group would say one thing, another group would say the exact opposite, and so it was really interesting to see it actually happen. And now we know what happens when objects of that sort of size hit Jupiter and what we can expect to see when that happens. So
yeah. It's a shame that comet didn't hit Mars about 4 or 5 years ago. That would have been, because we haven't got the dense atmosphere of Jupiter. Got a very thin atmosphere of Mars, and then we can see what a real impact is like.
Well, we can always make one hit someday before we actually have humans living there. Be fun to see what would happen. Why not hit a kilometer-sized impactor or even 100-meter-sized impactor and see what happens?
That'd be good.
Yeah, it could be quite a interesting event for the various probes and equipment we got down there.
Yeah,
I know there's already cartoons circulating about the latest lander with its deployable drill and hammer, drilling into Mars to take its temperature, so to speak. I've seen quite a few cartoons come out. I think this was one on my, it's definitely on my Facebook page as well. So let me just no, I don't want to go onto Twitter. I've been on Twitter.
The Apollo astronauts did that on the moon. They drilled cores and put temperature sensors down. It's called the heat flow experiment. So they really were able to see the temperature change as you get further down in under the surface. So learn a lot about the surface of the moon that way, and we'd do the same with Mars now. So
yeah, I think they're really interesting. I think, of course, there was that real big panic over that one comet that was coming in, because it was thought to going to graze the atmosphere, and they huddled all the probes in orbit got shifted to the far side of the planet.
That's the one.
And I think it's really a shame, because I think we could have got some fantastic images if something had been just in the right position to watch it go past Mars without the planet in the way. I know they took. I try to remember, they took some pictures from the surface.
They did, yeah.
And that was impressive. But I think it'd be more impressive to have something like MRO image the comet as it went by, and because I think that would have been on so many desktops within about a week as wallpaper. Martian comet. But maybe that would be one way to terraform Mars, is to find some nice water-rich comets, and before we actually get nicely set up on Mars, bang.
Take a few years.
Yeah,
it would.
Well,
definitely.
Isn't it fun? We can speculate like that.
Yeah. Well, there's that Mars trilogy of books by Kim Stanley Robinson. There's lots of fun to read, and they're talking about terraforming the planet as well. But one of the options certainly is impacting objects to change the atmosphere a little bit, or a lot.
And of course, you would need to jumpstart the planet's magnetic field again as well, because we know that's pretty much dead as well. So that would also help with solar radiation protection. Well,
or you got to have more careful habitats that protect you from that kind of thing, or something like that. Anyway, so
well,
let's go.
Yeah, let's. Well, they're talking about using indigenous materials to build the habitats, because the big issue, obviously, with using metal in your habitat is when radiation goes through metal, you get alpha, beta, and gamma particles spray. So yeah, it's almost like being inside an X-ray machine, I suppose, or something. Because every time something hits your habitat, you're going to get a fairly nasty dose of radiation.
Well, you just need to bury your habitat under lots of soil, and then you don't have that problem.
Oh yes, and again, that's something they're looking at for the moon. Is building habitats in lava tubes.
Yes. Yeah.
But it is
fun to think about those things.
It is, yeah.
At least you'd have heating.
There you go. My sidekick from the Event Horizon, my daughter, she's known on the show as Starstorm. She loves to make comments, and the thing is, she points out it would help with the heating of keeping the habitat at a good temperature for the colonists. So
yeah.
But it's. I have to admit, I'm getting kind of hopeful about Africano at the moment. It's at 10.5 magnitude, but it may actually do quite well, and it may actually be a decent comet for binoculars.
It will.
And I think this is the problem with 2017 T2 at the moment. No one can actually decide the magnitude, and I think a lot of people are getting antsy. They want to get out there with their telescope.
Yeah.
Yeah, there's a nice conjunction. It's going to be near the Pinwheel cluster at the end of October, so I'm hoping it's bright enough to be able to see that.
Yeah, I think it's going to be quite a nice object. Hopefully, it's a bit of a gassy object, but a lot of comets these days tend to be like that. for
Yeah,
some
we've
reason.
not had a decent one for quite a while, have we?
No, not a dusty one.
Well, I'll go out and see if I can find one. Maybe one of my 21st magnitude comets will get up to bright enough to be seen by Alan Hale.
And to be seen in the Northern Hemisphere for a change.
Yes. Yeah. It's we're in a bit of a drought, aren't we, at the moment? I mean, there's not a lot coming next year either, I don't think. I mean, maybe one. I think a lot of people are looking out for this 2017, is it K2, which was discovered a very long way away, was very, very active. And I think David Jewett wrote a paper on it and got the Hubble Space Telescope to look at it and everything. I think that's correct.
Mm.
That one could be a monster, but I don't think it's going to be very favourable from the Northern Hemisphere. Surprise, surprise.
Yeah.
Yeah, we need a second home in the Southern Hemisphere.
We do. We should holiday for when the bright comets come.
Sounds like a plan.
It does.
Or just use SLU.
Well, I'm guessing that Nick may have dropped out. I don't know. So just in case it has.
It got quiet since...
Yeah, sorry about that. I'm still here, chaps. For some reason, my mute button got activated. Don't know
I
why.
was just about to say that since we were last on in about 1987 or whenever we did the last show.
2 months ago, Neil.
Oh, okay. ESA, the Comet Interceptor mission has been fully stamped and approved for a 2028 launch, I believe. Shall we talk a little bit about that, do you think?
Yeah, let's go for it.
I haven't heard anything myself, so...
Oh.
No, tell us more. I don't think I'm up to speed with this one either, Neil, so it sounds great.
Oh, yeah, the ESA fellows have they put loads of missions forward, and the Comet Interceptor 1, it will be launched in 2028, and it will go into the L2 region, Lagrange 2, and it will sit in space basically and wait patiently until we discover a comet basically from the Oort cloud, or maybe another Oumuamua, who knows, something like this, where they're not going to bother with, like they did with the Rosetta mission, with the Jupiter family comets, because I guess they've all been looked at to a certain degree, so they want a fresh specimen, which is something we've been talking about on this show for a long time.
Yeah.
I know we bandied around that idea ages ago, didn't we? Getting an Oort cloud comet, and I think it was Elizabeth Warner we spoke to about that, and she said, oh well, it's impossible, of course it is, but apparently it's a goer.
I put a link into our Facebook chats so that Jim can see it as well. I've pulled up the ESA mission page. Okay, so it's we're getting 3 spacecraft.
Yeah.
This is basically, they're building on Giotto, they're building on Rosetta, and the really great idea with it's going to be a fast or F-class mission. Basically, the fast refers to implementation time. Oh, good gosh! I actually went
Make up your own words.
Yeah. So they are going to have a launch mass of less than 1,000 kilograms. It will share the ride into space with a medium-class mission, taking advantage of additional space on the launcher and boost to the Earth's Sun Lagrange point L2, which is about 101.5 million kilometers behind the Earth as viewed from the Sun. It's probably going to hitch a lift with the aerial spacecraft. They're both going to L2. And that from there, Comet Interceptor will journey onwards to its chosen target using its own propulsion. Now, this has also actually been a very, very fast selection process, which was unusual, because they did a call for missions in July of 2018. 23 pitches were submitted by the space science community, and 6 teams subsequently were invited to provide more detailed proposals. Amongst them was the Interceptor team, and that was actually chosen. I tend to think it's nice to think we actually suggested this whole idea in the first place on the show. So this is one for us, I think, really.
It's a bit like The Simpsons, isn't it? When the Simpsons predicted things into the future. Remember, have you seen that thing where the Simpsons predicted 1,000 things that are going to happen 20 years later and all that sort of thing? And we did it.
Now, the nice thing is, it's going to actually carry a camera that's based on the one currently on the ExoMars Trace Gas Orbiter. So it's going to have dust fields and plasma instruments, mass spectrometer, just like those that flew on Rosetta. So
I wonder if they get a quiet period. I wonder if they'll try and intercept Halley on its way back. If there's nothing.
That's
what do you reckon?
A little while off in the future there still.
Well, yeah. I like to think ahead.
Well, we have to think ahead because, to be honest, it is one of our most famous comets. Okay, it had a vast armada go to it. And I was actually still at Marconi's at the time because I actually worked on some of the flight model and EM kit that was being shipped out to ESTEC for the Giotto mission, and I actually have in my toolbox the mission badge for Greg Scullerup. In fact, one of our group members worked on that mission, Gerald.
Really?
Yeah. What do you
Well,
think?
it's interesting. It's interesting to study different kinds of comets like this because that we really think that the Jupiter family comets and the long period comets come from two different sources.
Yeah.
So studying them will tell us a lot about those two different sources and help us really understand where they all come from. You could easily think of Halley as maybe a long period comet rather than a Jupiter family type comet. So you might be able to make a mission toward one of those kinds of comets and sort of be studying the long period comets indirectly, although they've been contaminated a little bit more by close approaches to the sun. But still, they come from probably the same source. But waiting for a comet coming in from the Oort cloud, you generally have a very short amount of time to do anything with it. So you really have to have something maybe sitting out there parked, waiting to go, ready to go when you find an object, and then direct it off to that object fairly quickly. So this sounds like a really cool mission. It'd be fun to see it through its whole mission.
Silly question, but how do we know for sure that it hasn't been into our solar system before?
Well, because the long period comets are near parabolic, so it's possible they have been in a long time ago, but they're on orbits that take something like 1 million years to go around the sun. So there's a really good chance that they were perturbed into that orbit when they were sitting out there and they just dropped in for the first time. But there is a chance that it made a close approach, maybe not as close. If we see an object coming in that's going to be, say, around 1 AU from the sun, it's possible that it might have had a previous orbit where it was at 1,000 AU from the sun at perihelion. So, we can't say for sure, but I think we know the class of objects well enough to generalize them a little bit that way.
And of course, the nice thing is we can now do spectroscopy when they're quite far out, and we can get a very good idea of what they're composed of, which gives us makes us ask more questions like what was out there in the proto-solar system that isn't now? Where did it all go? Did it go into the gas giants, or was it perturbed? Was the actual perhaps the elements were perturbed by close approaches from outside the solar system, or what? We really don't know. And of course, the other brilliant thing about this mission is we get another Oumuamua that we can say this is definitely going one way. We can probably send a mission to it. We can actually go there and have a look at it. They don't really tell us much about what the propulsion system is, so I suspect it may be one of the ion propulsion systems that NASA's been having a lot of success with. So again, it's really a case of we are building on so much of the legacy missions and saying, okay, we can do this. This is what we need, and in some respects, most of this kit is off the shelf. which I think is the really great thing. So yeah, everybody says, it's 2028 or something that's going to go, but it isn't really a long time. Not when you're building spacecraft, and if you are really using off-the-shelf components, there may be an argument for the mission to be accelerated and perhaps to go earlier, particularly if something is detected far out by one of the surveys or something, or there's a determination, well, we really need to know about this object. Maybe we can push for Comet Interceptor to be started, maybe even if it's just an extra unit built and launched. ESA has the facility to do that. They have Ariane, they have the Vegas, they have the Russian systems, all at Kourou. So finding a ride may not be a big problem if there's a suitable urgency to perhaps push this mission ahead of when it would normally actually go out. So who knows? But the thing is, somebody obviously has sat down and listened to the community. And who knows, maybe they've even listened to our show. I don't know. I'm going to say they probably did, because we've all discussed this amongst ourselves on previous things what we would like to do. And hearing a bunch of people, not only amateur astronomers, but professional people like yourself, Jim, discussing this and saying how great this and how important this would be. Maybe someone has got off their duff and finally said, yeah, okay, let's look at it, let's get proposals in. This whole team is being led by Geraint Jones of the UCL Mullard Space Science Laboratory and Colin Snodgrass of University of Edinburgh. So they're the team leaders. Now, I will actually put the links for this into the show notes on YouTube, because I think really this is a mission impossible, but it's a mission that has to happen.
I mean, I know, going back a little bit, I mean, David Jewett would have loved to have seen it if we could have gone back in, going in future. He'd have loved it to have gone to K2, 2017 K2 Pan-STARRS.
I think Patrick would have loved it. He would have been over. He would have been. I think he would have been refusing to let Chris.
I saw him.
Trip.
Yeah, I saw him on the YouTube looking over the data from Giotto with Comet Halley, and also then the lady was talking about the follow-on mission when it went through Greek Skelly up or whatever the order it was, and he was sitting there and he's sitting right forward in his chair and he was loving every second of the data. I thought it was brilliant. So did I, actually.
I think we're lucky. We still got one of the great populists, certainly in the UK. James Burke's still with us. He was on the Sky at Night show commemorating the 50th Apollo anniversary. He would be perfect for the Sky at Night, because he is just as insistent on the facts and getting the answers to the questions being asked.
Yeah, it seems like you should be able to build 2 or 3 of these spacecraft and go to a couple of different long period comets that come in, and maybe even have another version of the spacecraft with a bigger engine that could go visit one of the Jupiter family comets and do the same kind of study, except maybe from orbit. Like we did with
yes, please let's go do 29P.
Yeah,
that one's pretty far out, but it would certainly be a very interesting object to go study in great detail.
Well, we know we have accurate idea. We have an accurate timing for its outbursts. So anybody, if they were to say, well, it's too dangerous for the spacecraft, that's a load of Tommy rot, because we know its timeline for an outburst, and we can plot it, and it's like I see comments in all the comet groups all the time saying, well, we're waiting for the next, I think it's 56-day period for our next outburst from 29P. We want people still looking at it all the time, even though it's not an outburst, because we want to catch it as often as possible.
In outburst.
Yeah. And we know we can time it. We know where it is in the solar system.
Yeah, studying the surface of that thing would probably tell you everything you need to know about why it does its outbursts in the first place.
Yeah.
So that'd be a great object to have a mission to. It's just so far out, beyond Jupiter there that it's going to take a while to get there, and there's not very much solar power if you wanted to run with solar panels or,
No.
things like that would be. It's still. I'd love to go see it. Let's go.
We don't need solar panels because the RTG technology that was employed on Voyager is still being used today. It's being improved all the time. Mars 2020 is getting its own RTG power pack. It's really, really getting to the point where they know how to build this kit. They know how safe it is. They test the casings for these radioactive isotopes so they know what it would take to break them. And of course, everybody was saying, "Oh, what if the rocket blows up on the launch pad?" Well, guess what? Nothing's going to happen to. You're not going to get radioisotopes everywhere because that's one of the tests they do. They simulate a launch explosion, and the casing so far that they've used, the casings have never ruptured.
Yeah, we sent them to the moon with Apollo, and one of them came back to the Earth with Apollo 13.
And the whole thing was, we learned so much. I believe on one of the Apollos, the missions, they actually went out to one of the either the Ranger or Surveyors that soft landed and took back
Surveyor
a sample,
3 on Apollo 12.
so that they could actually see and measure the degradation of metals exposed to the solar wind, which is very important for long-term space missions. So we have an idea how the metal changes, if it does at all. So we have the technology, as they say. Let's do it, and let's get using it. Yeah, thank you, Starstorm. And maybe actually have two versions of the Comet Interceptor. Have the current version, and then build maybe just one or two with a more powerful ion engine, or maybe a mix of chemical and ion technology, and so that we can do a fast intercept if something really spectacular comes in on very short notice. Oumuamua caught us with our pants down, literally.
Well,
sort of
you,
about
Nick, but
well, if you remember how people were reacting at the time, because at first it was thought it was just a rock, and when everybody started to twig that it was actually not a regular piece of rock, it was actually transiting the solar system. A lot of people really weren't up to speed, and there was a scramble to image and radar survey it. So this is what Comet Interceptor will actually perhaps prevent, and then we can start finding more objects, more comets. Maybe we can go to one of these funny little objects that start suddenly just becoming a comet, switches on and displays cometary appearance, and then switches off again and becomes, it's just another piece of rock. That would be another great place to go and visit, because 1 minute it's an asteroid, then it starts to produce a tail and everybody's scrambling to change it and have it reclassified as a comet, and maybe a few months later it switches off for some unknown reason, and it's back to being an asteroid again for designations.
Yeah. Well, there are some main-built comets that are behaving a little bit like that. It'd be fun to go see some of those too. So.
Absolutely.
Too many objects out there that are really interesting to go see. Let's go. Let's go now.
Yeah,
Definitely.
Let's start building spacecraft to get us there. Let's go. Let's send the old Mark 1 eyeball there. I love the robots. I love the probes. They do brilliant work. But at the end of the day, let's start sending humans to look at these things. Let's send people to actually visit a comet, and maybe if we're really, really clever and really careful, let's track it in, put an instrument package on it, and then sit back and watch the changes as it comes in and goes out back into the icy depths of the solar system.
We need some really big rocket engines. Where's the Enterprise when you need it with warp drive?
or even a shuttlecraft or two.
Yeah.
But
Yeah. If you're going to send humans, you got to bring the humans back. But if you send a spacecraft, you don't have to worry about bringing it back. So there's a lot to be said for unmanned spacecraft still for a while anyway.
Oh yeah. The thing is though, it's interesting that both the UK and the US did a docudrama series based around the concept of a united world spacecraft that toured the solar system. The BBC version was Journey to the Planets, and they interestingly both kept the same. Both spacecraft looked scarily similar, and they both had the same name, being called the Pegasus. But the idea was it was a spacecraft that would meet up and refuel as it got to its various targets, and then the crew could make a command decision: do we go further out into the solar system, or is it time to turn around and come home? It was kind of along the lines of Arthur C. Clarke's USS Discovery in 2001.
Yeah, when you're going to visit comets, comets have a fuel source on board already, so you can mine the comet and stock up on your fuel to get back to home or to go some other place like that. That sounds like a good mission.
Well, I'd be happy to go one way. And so were many thousands of other people when they did the Mars One thing.
It would certainly be interesting, and I think it also being able to image a comet from Mars properly will certainly be very, very different.
So you mentioned earlier about possibly getting infrared observations. I don't think I've ever seen any infrared observations of comets before. What would that benefit us with? What's it going to show? I'm being another silly question. Sorry.
Well, I think the thing is, in some respects, it was one of those things that helped in the discovery and confirmation of Araki Alcock. IRAS was it's the first time that a space telescope, I think it's the only time a space telescope has actually been allowed to have its name on the discovery of a comet, because it was looking in a part of the spectrum that we can't look at because our eyes aren't attuned to it. And
there were several comet IRASs. Hartley IRAS, for example, was another one. Trying to think if there was a Comet Wise. I don't think there was there?
No, but it's interesting the fact that the actual observations complemented the visual stuff from Earth, and as I say, near infrared could be very interesting. I know a lot of people who have a complete filter set. They have near infrared. Sea level is a bit difficult, but who knows? Maybe it will see things in that we can't visually detect, and it will also. And my view is that it will also augment spectroscopy of comets, because that will give you a greater understanding, perhaps, of what is going on. But that's just my idea.
It also gives you an idea of the thermal properties of the object too, which tell you something about how dark or light it is and what it's actually made of. So there's definitely a lot to be learned there.
Yeah, that's true.
So it's been an interesting week, I have to admit. No one really saw ESA's little gem coming. I haven't seen any real posts about it in the big wide world. This is one that seems to have slipped out and around a lot of people. I'm just trying to see what the...
It was the subject of the latest Sky at Night, which was last weekend in the UK. They were actually over there when they got the call.
Yeah.
In the meeting.
I think that is probably the greatest thing about a show like that. It does it's actually been a newsbreaker. With the mission being confirmed and being told to go ahead. Officially, it was all approved on the 19th of June.
Yeah.
So it makes you think. That I've not seen it on the BBC website or anything yet.
We're just waiting for the press story that'll have some crazy photograph of an alien tower block that they did when Oumuamua came in. Oh, we're sending out an really expensive spacecraft to look for alien skyscrapers. I'm just waiting for that story to happen.
Well, Arthur C. Clarke wrote the book on it a long time ago, Rendezvous with Rama.
Yeah.
Yeah.
And that's what a lot of people were. That was a lot of the stories I saw. Has Rama come through? Are we really facing an alien space probe? And of course,
probably not.
Larry Niven had his version with Ringworld, but
well, I've been waiting for a long time for an interstellar comet because way back when I was first getting into comets, I remember reading a paper. I don't remember the author for sure, but the idea was that interstellar comets would be debris left over from star formation that was ejected during the process, and the amount of material ejected during the process of star formation was a big variable in all their models they were using for finding out how the sun got here and other stars as well. So they figured the first time you saw an interstellar comet or an interstellar object of any kind, that would put a number there for you. It would tell you how many of those objects are out there per cubic light year or whatever the first time you see it. So to me, that I was really excited to hear about this object being an interstellar object. So I need to go find that paper and see what it had to say.
And of course, the other thing is they reckon that Jupiter's already captured another one, possibly. I'm saying possibly here.
Yeah.
Well, yeah. How do you tell them apart from something captured from our own solar system, though?
That's the hard part, and I think that's why, with Comet Interceptor being given the green light, if we get something like that come through again, and to say it's not going to happen again, it is probably really tempting fate, because the universe loves to. The universe is sitting there. Oh, look how complacent the humans are. They're saying I can't do this again. Suckers.
Well, if you can see small enough stuff, there should be a lot of interstellar debris flying through our solar system all the time. So
yeah,
should be.
And
what do you think about Comet 96P? Is it Machholz? They think that might be an interstellar comet because it's carbon depleted or something like this. This is from memory. I'm not looking at Google right now. So.
I'd be a little surprised to make such a claim. I think the comets, they formed out of our solar system, and where they formed could be quite variable. But I think making a claim like that is, I think, needs some more work.
I think so.
Yeah. I think that you could probably come up with a good explanation for how that could have come from our own solar system too. So,
yeah,
but I don't know the answer, so don't quote me on that.
None
one.
of it too. No.
We just have the questions.
I was going to say, Nick, we're talking about Oumuamua and this Comet Interceptor. I mean, would it keep up pace with it? I mean, this thing was. I mean, it's travelling at 26 kilometres a second right from the edge of the solar system, and by the time it gets here, it's travelling at, I don't know.
Yeah, it would have to be simply a flyby, sort of like our first missions to Halley. They put themselves in Halley's path and watched it go by. So that's how you would have to do that. There's no way you could have the Delta V in such a small spacecraft to rendezvous in orbit or stay with it.
Right.
No.
Yeah.
Okay, so I'm looking at something about 96P right now. Basically, the story starts back in 1986 when it was discovered. When it was tracked and its orbit determined, it's got a rather peculiar orbit. most of the planet's asteroids and many comets orbit the Sun in the same plane, making the solar system look a bit flat when viewed from the outside. This comet, however, is tilted from that plane by about 60 degrees. So,
Unusual for a short period comet.
exactly.
Very unusual. Very, very
But-
unusual.
But not too surprising. Early on, there was a lot of discussion about where do the short period comets come from, and originally people were trying to make them come from the Oort cloud, like all the rest of the comets. And if
Yeah.
you do that, then you should see a distribution of short period comets that have a wide inclination distribution. There'd be more in the plane of the solar system like we see, but there should still be a few that are retrograde and things like that. Halley is not a Jupiter family comet. It's a intermediate period comet and not a Jupiter family, so it's not quite the same thing. But occasionally you should see some retrograde short period comets appear out of the batch. But the thing was, there aren't very many of them. In fact, I think there aren't any that are retrograde that are Jupiter family, which almost every model trying to get the Oort cloud comets to make the Jupiter family would create a large number of retrograde comets. And so the models just didn't fit. They didn't work. So that's where the idea maybe started, that we had to have another source for the Jupiter family. And I think you can trace that right straight out to the Kuiper belt.
Yeah.
Yeah.
The other
I
thing,
think we have a better story now.
the other thing, of course, is that we've discovered fragments from it on one of the previous passes, and of course the carbon issue is why people are thinking of it may have actually been hijacked from another solar system.
Yeah. Well, what if it's really that first Oort cloud remnant that is on a high inclination orbit, and maybe it's telling you more about the Oort cloud comets
Yeah.
than the Jupiter family comets. So I don't know. We can arm wave for a while, I think, here.
Yeah. I think that 96P would perhaps be a good target because of A, the inclination, B, it's got some now the information I'm using is coming off the Armagh planetarium site, so that link will go into the thing.
It has the close perihelion though, doesn't it? It's quite a close one, isn't it?
Well, yeah, because they've actually got some spectacular images
Yeah.
on SOHO on the LASCO C2. And
Yeah, I thought
in
it did.
2012, they think they discovered an A and B fragment of the comet itself.
Yeah.
So
It's breaking up.
It's fragile, like all the other comets
Yeah.
probably are too.
Yeah.
Yeah. Well, let's go study it, but
Yeah.
we should also make sure we study some of the Jupiter family comets too.
Oh, yeah.
But dynamically, if it's high inclination, it's going to be a little more challenging. You're not going to be able to rendezvous with it, but again, you'll probably be able to fly by it, or have it fly by you, I should say. Yeah, different kind of mission, but
perhaps
let's go.
Let's do it, because it's a very as for being discovered, it's still a very young comet. I think they're talking about seven passes or something, 7 to 12 passes. So
Yeah, that is pretty young.
yeah. So it's been
Yeah.
out. It's been out there a long time, but it was only discovered back in the 80s
Mhm.
by Don
So-
Robbins.
Is that because then it maybe came to life, or it was inactive before then? Because it couldn't have been in that orbit that long. Surely it must have been in that orbit a lot longer than that.
It's a little over a 5-year orbit. It was discovered back in '86. So,
Yeah, so that's about 5 orbits or so.
yeah. So it's
So, it
I
probably
wonder.
was put into that orbit fairly soon before it was discovered. Could have been an orbit or two, and it'd be easy to miss it. So,
Yeah.
something it got in the way of perhaps Jupiter or Saturn, or one of the gas giants
Yeah.
gave it a kick, and then Jupiter captured it,
Definitely.
and I am grateful for it. It is going to give me something to look forward to. Probably you can convince me to buy a CCD, I suppose, at some point, and go for it. Why not?
Absolutely.
Oh, with that new scope, it deserves one.
It's going to be interesting.
Yeah.
Even though I'm going
And
to
of course, this week we had a nice Kreutz comet actually
Yeah.
hit the sun, didn't we, a couple of days ago? So it's been quite eventful recently.
Yeah.
One of the bright ones of recent times.
I want to address your comment earlier, Jim, about Kreutz, about these comets, because anybody who thinks that sun grazers rarely happen really need to be sat down and given a really, really good Gibbs.
Right.
Because
Yeah, the Kreutz family is a very well-populated family of comet debris. Brian Marsden was, I think, the first or one of the first to recognize that all these sun-grazing comets were in very similar sorts of orbits and probably came from a previous apparition of a bigger comet that fragmented when it passed very close to the sun. And so we're seeing the bits and pieces of debris from that earlier comet. And by the way, the object doesn't have to hit the sun to disintegrate and not come back out the other side. I'm not sure if this was a case where it did hit the sun or it just disintegrated, evaporated or whatever, as it made its close approach to the sun. I think most of them tend to not hit the sun but evaporate.
Yeah.
In the process. So, but they do happen very frequently. When the solar observing satellites like SOHO and others were put up there, it didn't for a lot of sun-grazing comets to be recognized in the images, and I know there's a number of people who actually look through those images looking specifically for sun-grazing comets like this one. So it's very exciting to see that kind of thing and this population of objects.
Yeah, guys.
So yeah.
I'm going to have
So
to.
they're all believed to have come from one parent comet that's broken up. Is that correct?
Yes, probably.
Guys, I've got a very heavy storm overhead, and I nearly lost my computer twice. I think we're going to have to wrap the show at this point because I think I'm about to lose power completely.
Okay.
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 Stay safe, Nick.
Yeah. So I just
Yeah.
want to thank you for coming, Jim. I hope to get you back soon. Maybe we'll do a part 2 to this show
Yes.
next month and pick it up again. So at this point, folks, I'm sorry about this, but the weather gods are being capricious. I nearly lost the computer twice already. So I think we're going to say goodnight for part 1. And we'll be back with part 2. Maybe we'll get together with Jim and we'll do part 2 very shortly. So
Well, it's always a pleasure to be on your show.
it's always glad to have you,
Thanks,
Jim.
Jim.
So
Thanks.
it's good night from me.
Good night from me.
Good
night.
night for me.
Good night or good day for me.
Good night, everyone. And
Bye.
look up.
Bye.
Bye.